Welcome back, mathematicians. What we want to do next is take a look at a slightly different problem. So this is going to be our, let's say a plus. Make it a plus video. So this time we're looking at a negative quadratic. Oop, my 2 disappeared. There you go. Negative quadratic. And this is a very, very common problem, right? The textbook is just filled with them. And what it is it's a projectile problem. So they'll have some cannonball or javelin or flying fish or something being shot up into the air, thrown up into the air, and then falling back down to Earth, right? So all of these objects react in a parabolic fashion, which is really nice for us, right? Things are easily predictable, things can be figured out. So in this case, what I'm looking for is to find the maximum height for a cannonball with this that is represented by this function, and I want to find the height of the cannonball, right? And if we think about it, let's see, let's draw a little drawing here. And unfortunately, things being the way they were, I put the cannon here, so let's just imagine it's lined up with everything. The height of the cannonball is also going to be our vertex, right? So our vertex is going to be the highest point of our cannonball. So we'll try to find the vertex. We can even find the x value. So you know, where's this point on the ground if we wanted to, but that's a later issue. And we also want to find where it lands. So maybe we're shooting at some building or some castle that's like perched itself in this general area. Okay. Castle math. All right. So anyway, let's make one of these things. Let's start with the height, right? Height should be relatively easy for us, right? So I'm hoping we already know it. Maybe we do, maybe we don't. But again, I'm looking for the vertex, right? So the height in this case, oops, let's actually do this a different way. Let's call it height. Some of us know physics, right? So height is going to be equal to our vertex. Let's figure out our vertex. Our vertex is going to be at, well, we can do it from this one, right? So I have negative 10. That negative 10 minus 10 squared plus 200. Negative 10 tells me to go which direction, right? So that way. 200 tells me to go that way. And so my vertex, so our vertex is going to be 10 in the positive direction and 200 um, and also in the positive direction. This one is going to be our x value. This one's going to be our y value. So there you go. So our maximum height would be 200 feet. Okay. And if we want to find out the distance, we actually want to find where the landing is, or the zero, right? So our zero is going to be, what we're going to have to do is set our y value to 0. And if you think about it, this really does make sense, right? Let me try it. Minus 10 squared plus 200. This is a 0, right? This is where that graph crosses the x-axis, and this is where that graph, or this part of the graph crosses the x-axis. And for both of those, my y value is 0. So what am I going to do? I'm going to make this f of x, or y, equal to 0. Okay, so let's figure that out. I'm going to figure out in a kind of traditional fashion here. See if I can scroll up a bit. There we go. So I'm going to subtract 200 from both sides. I'm going to separate these out a bit. Right, subtract 200 from both sides. That's good. Oops. So then I'm going to get negative 200 on one side, minus 10 square that. Okay, so now what else do I want to do? Well, I want to get this 10 off of this x, and I want to get this squared off of it, and I want to get this negative 2 off of it. So start with the negative 2. I'm going to divide by negative 2. And if we want to think about it like just one constant, right? If we just had a negative 2y squared, we'd still divide by negative 2 first before we square rooted anything. All right, so that leaves us with a positive 100 is equal to x minus 10 squared. Okay, and then what I'm going to do is to get rid of the squared, I'm going to square root the function. Right? So this is where I have to kind of be careful. The answer to this is not just 10, right? A lot of us are going to say, well, that's easy. 10 times itself is going to give me 100. I'm done, right? Almost, right? What we need to remember is that this is actually plus or minus 10, okay? Plus or minus. I get two different answers, and if we look at a parabola, that is what is expected, right? I should get a plus 10 and a minus 10. So let's split that up. Okay. I'm going to write two different equations. In one case, I'm going to look at if I had, in one case, right, I'm going to put it over here, I'm going to get a positive 10. So what was expected before, x minus 10. And then I'm going to, in the other case, I'm going to get a negative 10, but I'll take care of that in a second, just because of, I have this one in front of me now. So I have x is equal to 20 as one of my answers. And then, let me go over here. And then on this side, I'll have a negative 10 minus 10 is equal to, so when I add 10 to both sides, I get x is equal to 0 in this case, okay? So again, in one case, I had a positive 10 on this side, and in one case, I had a negative 10. And that all comes from right here. So this is going to be my negative 10. So in one case, I had a negative 10, right, in green, and that went over here. And the other case, I've had positive 10 in blue, and I put that over here. So my two answers are 20 and 0. So obviously, we know that our cannon started from 0 on our graph, and it landed at 20. So the distance from our point of origin, at the origin, is going to be 20. So this will be the answer that we want. Okay? So thanks for listening. I'll catch you guys next time.